Welcome back, everybody. So we're going to take off where we left off, and this video is going to be more focused on using these gas laws mathematically to solve for unknown variables. Okay, so this is worksheet 8.2 that we're looking at right now. If you printed it off, great. If you just want to copy it down on notebook paper, that's fine as well. But we're going to do the problems that are on worksheet 8.2. So on the top, we see our four gas laws that we're familiar with, starting to get familiar with. And what we're going to do now is practice rearranging them to solve for unknown variables. Now, if I read the directions, it says solve for V2 for each of these equations. What do I mean by that? If I'm solving for V2, I want it to be by itself. So if I'm solving for V2, I need to know the other three variables. So this is essentially an algebra problem. Okay, to get V2 by itself, you can cross multiply. Or how would I get P2 over to the other side? Divide. Okay, so there would be my new equation that has isolated V2. So if I knew P1, if I knew V1, if I knew P2, I could solve for V2. For this one, take a second and try to do that. And I'm going to go over it. So here, how do I get V2 by itself? I just simply cross multiply, move T2 to the other side. So my new equation would be V2 times V1 over T1 equals V2. Now for this one, I don't see V2, so in the directions it says solving for T2. Now this one's a little tricky because I'm solving for a variable that's on the bottom. So if I simply cross multiply here, I end up with P1 over P2 times T1 over 1 over T2. So I end up with an inverse. I can't solve for that. I like to, and there's multiple ways to do this, I like to move T2 up top, because that's going to be a lot easier to solve for, and then cross multiply. T1 up here, and P1 over here. So I move T2 up top so that I can solve for a variable on top, and then I move everything else away from it. So there would be my new equation, P2 times T1 over P1 equals T2. Now in this case, I'm solving for T2. Oh, excuse me, V2. Okay, so I'm doing, it's on the top, so I don't need to worry about any extra cross multiplying, and I'm just moving everything away from V2. So I move T2 up here and P2 down here. Okay. When I do that, there's my new equation, and I can simply plug in my variables and solve for my unknown variable. So in this video, I want us to be comfortable using all of these equations to solve for unknown variables. Now you're either going to be given 3 out of 4 or 5 out of 6 variables. You're going to pick which gas law you use and solve for that unknown variable. All right, so the little notes below it, it's up to you if you want to write them down or just follow along, but oftentimes it's going to be easiest to use that combined gas law, this one right here, okay? And then anything that's constant I can simply leave out. So if temperature is constant, I just leave it out and I'm left with Boyle's law. Or if Charles' law is constant, or if pressure is constant, I can leave that out and I get Charles' law. But you could pick which gas law you use or just always use the combined gas law, remembering that whatever is constant is left out. You also remember you must always use the Kelvin scale for your temperature, okay? Because you can't have a negative volume and you can't have a negative pressure. Okay, so the Kelvin scale solves for that. You're also going to see STP a lot. STP, if you don't remember, 1 atm and 0 degrees Celsius or 273 Kelvin. Typically, you're going to be using kelvins. Okay? All right, so let's look at our first problem. Now, the 4 steps you use to solve these problems are, step 1, identify the variables. What variables are you given? I like to underline them, label them. Step 2, write and rearrange the formula needed to solve the problem. So I pick which gas law am I going to use, and I rearrange that gas law to solve for the variable that I need to solve for. And then step 3 and 4 are simply plugging in and solving. Remember, your answer has a unit. All right, so the first thing I do, read through this and identify my variables. 19 milliliters, what is that? That is a volume, okay, of oxygen is collected at a pressure of, there is my pressure. What is the volume? So that's what I'm looking for at 760 millimeters mercury pressure. So this is my new pressure. Okay, so it looks like temperature is constant here, so I don't need to worry about temperature. And I'm just looking at volume and pressure. So I'm going to call this V1, this P1, and this P2. So it looks like I'm looking for V2. So I've identified my variables. Step 1. Step 2, what gas law would I use? If I look up top to this worksheet, or if I have them written down somewhere, what gas law involves pressure and volume? Hopefully, you know Boyle's law. Okay, temperature is constant, so I'm using Boyle's law, and then I'm rearranging to solve for V2. So if I rearrange and solve for V2, I end up with P1 times V1 over P2 equals V2. So I solve for that new variable. Okay. All right, now I can simply plug everything in. Step 3. Step 3, plug everything in and solve. Okay, so I'm going to plug all those variables in and solve. Remember, my units cancel out, millimeters mercury, and I'm left with my new unit of milliliters. Now here I didn't follow sig fig rules. I should have, okay? And I had 2, but I guess I wasn't picky on that here. But anyway, my new volume would be 18.37 milliliters. Sig figs with 2 sig figs with 760 would be 18 milliliters. Remember your units. Remember to show your work. That's number 1. All right, number 2, I would take a minute, pause, try to do it on your own, but I'm going to go through it as well. So number 2, I'm identifying my variables. 50 milliliters is a volume. Measured at 20 degrees Celsius, that is a temperature. If the pressure remains constant, so I can ignore pressure. If anything remains constant, you can ignore it. What will the volume be? That's what I'm looking for. So I'm looking for the new volume, okay, at 40 degrees Celsius, which looks like my new temperature. All right, so I have volume and temperature. I list my variables, but you should also remember, what about temperature? If it's in degrees Celsius, I need to convert it to Kelvin. So remember, with your temperatures, you convert to Kelvin, okay? I've identified my variables. Pressure is constant. Next, what gas law would I use? What gas law relates volume and temperature? Hopefully you know volume and temperature. We have Charles' law. Now I am solving for V2. So I'm going to rearrange this, move T2 up top, and there's my new equation. Now I plug everything in and solve. There's my cancel my units of kelvins, and my new answer, my new volume, is 53.41 milliliters. Sorry, I didn't follow sig fig rules here, but the correct answer with sig figs would be 53.4 milliliters. Make sure your answer has a unit. Make sure you've shown your work. That's number 2. One more example, number 3, and then I'm going to assign a few problems. Number 3, if a gas in a closed container. So a closed container means the volume is constant, okay? Is pressurized from 15, so there's my pressure, to 16, P1 and P2. The original temperature is 25 degrees Celsius. What would the new temperature be? All right, so I'm listing my variables. I'm looking for T2. So I have pressure and temperature. What gas law is that? Hopefully you know, Gay-Lussac's. And I'm solving for T2. Now here I'm solving for a variable on the bottom, so I need to do some extra cross multiplying. I move T2 up, and then move T1. Okay, I move T2 up, and then I move T1 up, and then I move P1 down. Okay? So there I have the rearranged equation for Gay-Lussac's law, solving for T2. So now I'm just going to plug everything in. Again, I've converted my temperature to Kelvin, and my answer is going to be in Kelvin. Okay? So when I solve here, my answer is in Kelvin. I could convert that to Celsius if I wanted, but I could also leave it in kelvins. And I followed sig figs here at 318 3 sig figs. Okay? So hopefully that gave you some introduction into these gas law problems. I am going to assign problems 1 through 7. Well, we already did 1 through 3, so there's really only a few more problems, okay? 4, 5, 6, and 7. So finish those problems. I'm going to have some extended practice as well if you want to earn some extra points. But also, one quick thing. I would write down which gas law you use every time, because that's going to help you remember what law is what. You won't have to memorize it, but it's in your best interest to try to remember. Put a name to those gas laws to help you remember those. So if you're using Boyle's law, write Boyle's law. If you're using Charles' law, write Charles' law. If you're using the combined gas law, write the combined gas law. All right? So hopefully that gave you enough information to solve the problems in worksheet 8.2.